What is up, geometry students? Mr. Master coming at you with the Unit 1 review video. Do my best to be as efficient as possible while being as descriptive as possible. So here we go. Question 1, point B lies on line segment AC. What is very important to maybe take note is that point B is not stated to be a bisector or a midpoint. So that means don't assume AB is equal to BC. We are told the length of segment AC is 20, the length of BC is 12. Okay, that means AB plus BC has to equal 20. So I can say AB is X, X plus 12 equals 20, X has to equal 8, line segment AB is 8. Question number 2, M is the midpoint. Now that means it splits it straight in half. Maybe not straight in half, but splits line segment JK in half. JM has a length of 8. MK also must be a length of 8. JK is a length of 16. So MK is 8. JK is 16, even though it's not asking me for it. I'm giving it to you. Point C, number 3, is between points B and D on a line segment. B and D on a line segment. So again, C we can't assume is in the middle. BD has a length of 24, so that's the entire line segment's length is 24. CD is 2 more than 4 times the size of BC. I don't know the size of BC. So I'm going to label BC's length as X. I'm going to say that CD is 4X plus 2. That's 2 more than 4 times the size of BC. So now I'm using X as a length. It's very important to note that this cannot be done with midpoints the same way. So maybe just be careful out there, guys. But we do have the equation that BC plus CD equals BD. So x plus 4x plus 2 is 5x plus 2 equals 24. 5x equals 22. X will equal 22 fifths, which will be 4 and 2 fifths. So 4.4. Great. But you just leave it as 22 fifths. All right, question 4. Point E is the midpoint of segment GO. We pay attention to the word midpoint. Midpoint means the middle. GO has a length of 18. Oh, great. That means we should know that GE is 9 and EO is 9. EO is 6 less than 3 times a number. So I'm going to say EO is 3x minus 6. Now there's 2 ways we can do this. We can either say that 3x minus 6 equals 9, or you can label GE the same as you label EO. GE can be labeled as 3x minus 6, and you could say GE plus EO equals GO, or double 3x minus 6 is 18, or 6x minus 12 is 18. You realize these two equations, 3x minus 6 equals 9 and 6x minus 12 equals 18, are essentially the same equations, just one's double the other. So solving either gives you x equals 5. Question 5, point L lies on line segment AG. Again, don't assume that L is the midpoint. Segment AL has a length that is 2 more than a third of length AG. Ooh. So we are relating one length to another length. AL is related to AG. It says AL is 2 more than a third of length of AG. Well, I don't know what AG is, so I'm going to label AG as X. That means AL is a third of X plus 2. LG has a length of 8. We have this very interesting situation, AL plus LG equals AG. Looks like algebra out there. 1/3 x plus 2 plus 8 equals x. Well, we have a third of an x plus 10 equals x. I'm going to subtract a third of an x from both sides. and I get 10 equals 2/3 of an x, I will then take 10 and multiply by 3/2 to solve for x. And I get 30/2, which is 15. And 15 is AG. That means AL is 1/3 of 15, which is 15 times 15 divided by 3, which is 5. 5 plus 2 is 7. So AL is 7. Okay, moving into angles. Angle MTH has the point A in its interior. MTH. Maybe it should have been MAH. Whatever. A in its interior means that A lies somewhere in the angle, and we create this segment TA, where we have the equation angle MTA plus angle ATH equals angle MTH. So the larger angle MTH is split into two smaller angles. Don't assume A is bisecting or cutting this in half. ATH has a measurement of 24 degrees. MTA has a measurement of 72 degrees. Well, that means MTH must be the sum of MTA and ATH, or 72 plus 24, which is 96 degrees. Now, number 7, a right triangle has two non-right angles. Okay, that is true for all right triangles. If one of those angles is triple the other, what are the measurements of the two angles? Well, very, very important in this question, number 7, is that we have a right triangle. A right triangle means one of the angles is 90 degrees. Now we know that the sum of all three angles add up to 180. Great, don't forget that. Or we realize that these two angles of a right triangle have to add up to be 90. So one of the angles is triple the other. So I'm going to just label one angle as x so that the other angle is 3x. Well, I know that x plus 3x plus 90 is 180, or 4x has to equal 90. X equals 45 halves, which is 22 and a half. So one angle is 22 and a half. The other angle is triple that, 67 and a half. Cool. Sorry. Question 8. Segment RG is perpendicular to line segment GT. Point I lies in the interior of angle RGT. Perpendicular. What does that mean? 90 degrees, people. 90 degrees. These little words mean so much. You have to pay attention to details. So line segment RG will make a 90-degree angle with line segment GT. We can see that those two line segments really just like connect with each other. Point I lies in the interior. Don't assume that it's splitting things evenly. We are told RGI equals 2x plus 10. Great. We're told IGT is 3x plus 50. Oh, cool. It's not saying 10 more than twice a number like we did in most of our lessons. What is x and what is the measurement of RGI? Okay, well, what do we know? RGI plus IGT equals 90 degrees. That's what I'm going to use. We can't assume that those two are equal to each other, so we will add them and set them equal to 90 degrees. So we'll get 5x plus 60 equals 90. We'll get 5x is equal to 30. We'll get x is equal to 6. That gives us that RGI, which is 2 times 6 plus 10, is 22. And then IGT is 3 times 6, which is 18, plus 50, which is 68. Does that work out? 68 plus 22 is 90. All right, given a situation where two parallel lines are cut by a transverse, creating 4 acute and 4 obtuse angles, if the acute angle is 4x plus 10, and The obtuse angle is 6x plus 50. What is the value for x? Well, the key to this question is understanding that in this situation, the acute and the obtuse angle are actually supplementary, or they add up to equal 180 because they lie on a straight line. So I'm going to add up the angles and set them equal to 180, giving us 10x plus 60 equals 180, 10x equals 120, x equals 12. That's the value of x, which is what I'm being asked. Angle ANG is bisected by line segment NL. ANG, bisected. Guys, pay attention to the details. That means this angle ANL is equal to angle LNG. ANG is 10x plus 20, or 10x minus 20. That's the entire angle. LNG is 4x plus 12. Okay, here we go. You can say that since NL is bisecting ANG, that ANL is equal to LNG, so ANL is 4x plus 12. You could say that LNG is actually half of the entire angle, so LNG would be like 5x minus 10. However you want to set up, either you can do 4x plus 12 equals 5x minus 10, or you want to do 8x plus 24 equals 10x minus 20. You could solve the equation and get the correct answer, that x equals 22. That means ANG is 10 times 22 minus 20, or 200 degrees. Sorry for the silence here. Just making sure we got this. 220 minus 20 is 200 degrees, is angle ANG. And 22 times 4 is 88 plus 12 is 100. Look at that, 100, 100, 200. Question number 11. Point P lies on the interior of angle MOE. Okay, MOE is the big angle. P is in the interior, so OP. Don't assume it splits it in half. MOP is 10 degrees more than half of MOE. Okay, I don't know MOE, so I'm going to say MOE is X. MOP is 1/2 X plus 10. POE is 30. This is very similar to the line segment question we had earlier, where we have 1/2 X plus 10 plus 30 equal to X. That's 1/2 X plus 40 equals X, or subtracting 1/2 of an X, 40 equals 1/2 of X. It means X will have to equal 80 after multiplying by 2. So MOE is 80 degrees because we labeled X MOE. Two parallel lines are cut by two transverse lines that intersect each other on one of the parallel lines at a point. We can see that we have one obtuse angle measurement that is 110 degrees, and then one acute angle is 60 degrees. Having a diagram is pretty crucial for this question. What we'll find is that we utilize the fact that angles are supplementary to each other, that one of the angles in our triangle is 70 degrees. Another angle is going to be 60 degrees. And then we find that the last angle would be 50 because it's the three angles that add up to equal 180. This is tough without a diagram, so if you don't have a diagram, don't worry. Make sure you have the diagram. That's for you, Leo. So question number 13, let's see. I think the rest of the questions we don't need a diagram. Great. Three angles of a triangle are equal to a number twice the same number and 60 degrees less than 3 times the same number. Okay. So we got angle 1, angle 2, angle 3. I'm just going to denote because it's three angles. I'll say angle 1 is equal to a number. So I'm going to say the number's x. That means angle 2 is 2x and angle 3 is 3x minus 60. So 6 degrees less than 3 times the same number. All right, so we have x plus 2x plus 3x minus 60 is 180. 6x is minus 60 equals 180. 6x equals 240. X equals 40. So the number is 40. The angles are 40, 80, and 60. 14. We got angle T, R, and I in a triangle. R is double angle T. I is 40 degrees more than R. What are T, R, and I? You guys have been doing such a good job with this, and it's actually opened up my eyes to an easy way to do this. R is double angle T. Well, I don't know what angle T is, so I'm going to call it X. R must be 2X. I is 40 degrees more than R, so I is 2X plus 40. I mean, like, you already know what R is. It's 2X. This plus this plus this equals 180. So 2, 4, 5x plus 40 equals 180. 5x equals 140. I need to divide 140 by 5, and that's going to be 28. So T, its angle is 28. R is double that, so that's 56. And I must be 56 plus 40, which is 96. So 28, 56, 96. Cool. 15, an equilateral triangle. What does it mean to be equilateral triangle? All the angles and the sides are the same. All the angles are 60 degrees. One of the angles is 20 more than 8 times a number. Well, I don't know what that number is, so I'm going to call it X. One of the angles, 20 more than 8x, has to equal 60 degrees. That's how we find the number. 8x has to equal 40, x has to equal 5. An isosceles triangle has angles D, E, and F. Angles D and F are equal to each other and are both twice the size of angle E. Well, I don't know what the size of angle E is, so I'm going to label it as X. So E is X, and then D and F are 2x. Okay, that's no big deal. So I have 2x plus 2x, or 5x's, which have to equal 180 degrees, divided by 5. I got 336. 36. Angle E must be 36 degrees. 36, 72, 72 must be correct. Just quickly do the calculations. Yes, 36. Cool. 17. An isosceles right triangle. Pay attention to the word right. Pay attention to the word isosceles. Isosceles means two of the side lengths are the same, which means two of the angle measurements are the same. Since it's a right triangle, that's a 90-degree angle down there. It's got a non-right angle that is equal to 30 more than 3 times a number. I don't know what the number is, so it's 3x plus 30. Well, here's the deal. The other angle must be 3x plus 30. That's one thing to do. And you can add up all the angles together and equal them to 180. Or, since you know it's an isosceles triangle, you've already used 90 degrees. The remaining two have to add up to equal 90, which means the remaining two are 45. So you could either take the 3x plus 30 and set it equal to 45, which is very easy to do, to get that x equals 5. 5 showed up a lot here. So that's the number. Or you have the 3x plus 30 twice, which is 6x plus 60, has to equal 90, or plus the 90 equals 180. Whatever you want to do to get that 6x equals 30 or x equals 5. Doesn't matter how you do it, the number is 5. This is question number 18. Two different isosceles triangles have the characteristic that one of their angles is 30 degrees more than double another angle. What are the angle measurements of the two different triangles? Well, we have the situation with the isosceles triangles that you know two of the angles have to be the same. Well, we could say that the different angle could be x, like the angle that we start with, which means the other two angles which have to be the same would be 2x plus 30. That is one situation we could have. The other situation is that the two angles that are the same could both be x, and the third angle that is different would be 2x plus 30. That gives me two different equations that'll help me find our two different angle situations. For the double 2x plus 30, we'll have a total of 5x's plus 60 equal 180, which means 5x equals 120, and x equals 14. So we'll have the angle 14, and then the other two angles are double that, which is 28 plus 30, 28, 38, 48, 58. I screwed up. X, 2x plus 30, 2x plus 30, subtract 120 to 24. Sorry, 24, not 14, 24. Sorry, 120 divided by 5 is 24. So 24 doubled is 48 plus 30, 78. 78 is 156, 156 and 24, 56, 66, 76, 4. Good. Great. So 24, 78, 78 is one answer. And for the other situation, we will have xx and 2x plus 30 to give us 4x plus 30 equals 180. 4x equals 150. We have to divide 150 by 4. I'm going to start by dividing it by 2, and I have 75 halves. 75 halves is 32 and a half. So I'll have 32 and a half twice. And then if I double that, that's 65 plus 30, 65, 75, 85, 95. So 95 in 95 and 75. 95 and 85. 95 and 85. So that's wrong. What did I make a mistake with? 32 and a half doubled is 65 plus 30. What's 75 divided by 2? 36, 37 and a half. No. Yeah, 37 and a half. My bad. The old mental math fails me. So 37 and a half, 37 and a half is 64, 60, 74, 75, 75, and 105. I think that's right. If you have a calculator, great, use it. 37 and a half, 37 and a half. 75. 75 and a half. Cool. Let's make sure that's right. 37 and a half doubled is... Yeah, we're good. All right, sorry about that. Question number 19. Two parallel lines are transversed by a different set of parallel lines. We should envision that we create 8 acute angles that are the same and 8 obtuse angles that are the same. Okay? An angle created at one of the intersections is 70 degrees. Well, that means that's the acute angle. The obtuse angle must be 110. All the angles are going to be 70 and 110. So that means the 4 angle measurements of the quadrilateral, since these are 2 sets of parallel lines, must be 2 70s and 2 110s. Question 20, almost there. Quadrilateral. Draw some random quadrilateral. Don't assume that it's going to be a rectangle. It's got angles A, B, C, D. Angle B is twice angle A. I don't know what angle A is. I'm going to call it X. That means B must be 2X. C is 10 more than double angle B. So I'm going to double angle B to get 4X, and I'm going to add 10 to it. So angle C is 4X plus 10. Angle D is 40 degrees more than angle A. Pay attention to it. Angle A, I said, is X. So that means angle D is X plus 40. Adding all these angles up has to equal 360 degrees because a quadrilateral is two different triangles added up together. So I have 4, 5, 6, 7, 8 X's plus 50 equals 360. 8 X's equals 310. Is that right? Yikes. 10 more than double angle B. 40 degrees more than angle A. I feel like I thought this is going to work out better, but it doesn't. But 310 divided by 8 is 100 and so it's 15. 155 over 4. I can't divide by 2. Let me divide by 2. I can do this. 310 over 8 is the same as 3 divide by 2, divide by 2, 1, 5, 155 fourths. All right, that's the best I could do, 155 fourths, and 155 fourths is 38.75. Great. Not a great number. If you have a calculator, please bring it. Okay, the length of a rectangle is 5 more than double the width of the rectangle. So it's a rectangle. Rectangle has two of the same lengths, two of the same widths. Sorry, my cursor just froze. Be right there. Wow. Computer is really slow right now. All right, cool. Maybe because I have the calculator open? Hopefully not. So I got two widths. I'm going to call them X. And then the length is going to be 2X plus 5. I'm told the perimeter is 40. Well, the perimeter is the sum of all the side lengths. I have 2, 4, 5, 6 X's plus 10 equals 40. 6X equals 30. X equals 5 again. I think we're getting all the 5s out of the way, and you won't have any 5s on the test. I don't want to say that, though, because you might have a bunch of 5s on the test. So the length is 5, the width is 15. I created all these questions, so blame me. And then 22 is a good question. It's not numerical, so it might be confusing to some students, but key is to draw a picture and then kind of go off of that. We have a rectangle ABCD. Okay, ABCD with lengths AB and CD that are double the widths. I don't know what the widths are, so I'm going to label it X, and I'm going to say that AB and DC or CD are 2X. I am adding equilateral triangles on top of this. Two equilateral triangles are placed so that they share the same widths as BC and DA. So I have to visualize that we have an equilateral triangle on a width, both widths. So imagine a rectangle, but instead of like squaring off at the ends, you kind of triangulate at the ends. So we have our long lengths, and then instead of doing a 90-degree cut to get a width, instead we are going to go diagonally with our two of our three sides of our equilateral triangle, which are the same. And since it's sharing a side of BC, these equilateral triangles, I know that all of these lengths are also x. So I have x, x, x. Now, if I asked you what is the perimeter of the shape, I would only refer to the lengths of the rectangle, which are 2x, and then two of the lengths of the equilateral triangles that are on the ends of this rectangle. But two of each triangle. So I have two 2x's, and then I have two sets of 2x's, which are two of the triangle lengths, for a total of 2, 4, 6, 8 x's to be the perimeter. If I want this in terms of length AB, I really have 8 ABs is the perimeter. I'm not including the width of the rectangle to be the perimeter of the object, as a perimeter is just the length around the outside. So I've got the two widths are 2x, and then I have the triangle, equilateral triangles, two lengths each, which are both x, because they're both the same as the width. Sorry. I have the doubling of the widths, which are the lengths. The lengths are each 2x. And then I have two side lengths of two equilateral triangles, each length x, for a total of 4 x's from the triangle and 4 x's from the lengths of the rectangle. 8 x's or 8 ABs. All right, that's the review. Do these and do them again, and don't get any of them wrong, and you will do well on the test. I'll see you out there. Peace.